Okay, class, today we will be talking about negation. And we've already talked about it in other contexts, but we're basically going to combine it with quantifiers today and see how that works. So let me write that down. So next we will combine this guy, the negation symbol, with quantifiers. So remember, we already looked at things like this. So what is the negation of a statement? It just means not that statement. So it's true if that statement is false and vice versa. We've also looked at how to negate an and statement and how to negate an or statement. So remember, those were called De Morgan's laws. So we realized that you could distribute it through, but you have to flip the symbol upside down afterwards. Okay, so now let's think about how negation might impact a statement that involves quantifiers. So here's a perfectly good statement now. So now we have our fancy notation. There exists an x in the real numbers such that, so remember how this works. You quantify what kind of thing x could be. You either say it exists or you say it always works. And then you say the predicate. So this would be something like a relationship about x. So how about x is less than or equal to 8. So there exists an x in the real numbers such that x is less than or equal to 8 is the statement. So let's try to negate it. So symbolically, what we're thinking about is something like this. If I negate a statement that looks like there exists an x in something such that the predicate happens, what is that going to look like? And we'll think about it just by thinking about this example. So if I say this statement and I want to negate it, that means I'm saying that it is not the case that the statement happens. So the statement in this situation is that there exists an x in the real numbers such that x is less than or equal to 8. So this is the negation of the original statement. But let's try to think of it in a nicer way. What does it mean to say that it's not the case that there exists an x in the real numbers such that x is less than or equal to 8? Well, one way to say it is to say that there does not exist, because we're saying it is not the case that there exists. So there does not exist an x in the real numbers such that x is less than or equal to 8. So then the trick is to think about it in another way. This way is sort of natural to say it this way. But the next way is sort of a jump. So if I'm saying that something doesn't exist, I'm sort of saying that this guy will never happen. In other words, for any x in the real numbers, this predicate will not happen. So what that's saying is, well, let me like write a weird notational thing. So it's sort of like saying this guy won't happen. But that really just means that for any x in the real numbers, x will not be less than or equal to 8, but that's just saying the negation of x being less than or equal to 8 is what will happen. So the negation of less than or equal to is greater than. So in general, what's going on is if you have a predicate, you are just negating the predicate. So if the predicate says that something equals something, then the negation would be that it doesn't equal. If it's bigger than, it would change into less than or equal to, and so on like that. So let me just write out the complete answer for this example. For any x, the real numbers, x is bigger than 8. That's the negation of that there exists an x in the real numbers, which is less than or equal to 8. And so what's going on is this is how it will always work in general. So what does the negation do? Well, it changes the there exists into a for all. So saying that something doesn't happen is the same as saying that for any x in whatever you're talking about, the predicate will not come true. So you'll negate the predicate. Right? So if you say there does not exist an x that does this thing, then you're saying no matter what x you use, this thing will not come true. And that is exactly what's being described by this relationship. And so by now you might see how like a pattern always shows up, which is like how things come in pairs. So like there was and or, and they're sort of like opposites of each other. And for all and there exists come in a pair. And when I negate it, it turns there exists into for all. So I bet the other way also will work. That's just how math always seems to work out. That's got to happen. And it will. But I guess I should give you one more example first. So if I say negation of there exists an x in the integers such that 3x plus 2 equals 4, that's equivalent to saying that no matter what x I use in the integers, it will not solve 3x plus 2 equals 4, meaning that 3x plus 2 will not equal 4. So this is p of x, and this is how you negate p of x. This is how you say it's not true. So let's think about the true and falseness, just because we should always think about that. So what is true in this situation? The negation is the true statement this time. So I guess I'll circle it. So this blue thing, that is false, right? If I said that there exists an x in the integers such that 3x plus 2 equals 4, that's false, because if I try to solve for x, I get x equals 2/3, right? Which is not in the integers. It's a rational number instead. So that statement is false. And the negation should therefore be true, because the negation is the opposite of the statement. So when the statement is false, the negation is true. So that means that this whole thing, this should be true. In other words, this should be true, because this is what we turned it into. So let's think about if that is true. So no matter what x you use from the integers, that equation will not ever equal 4. Yes, that is true. Will never be 4. Okay, so no matter what x you use from the integers, notice that that doesn't change when you negate it. That's still there. No matter what number you use from the integers specifically, the left side will never become 4. So the negation of the original is true and the original is false. Okay, so now let's go the other way and let's think about something like this. Consider the statement that for any x in the real numbers, x plus 10 equals 3. So now we're starting with a for any, a universal quantifier, instead of there exists. And once again, we're going to negate it. So let's do that. The negation is, so if I just stick this symbol on here, what is that going to do? Well, what you're saying in plain English is that it is not the case that this happens. So it is not the case that for any real number x, just saying it slightly differently, x plus 10 equals 3. So if it's not the case that every single real number makes x plus 10 be 3, you must be saying that there's a situation in which x plus 10 does not equal 3. So that's exactly what's going on. So you're saying not for any number, sort of sounds weird until you change it, not for any number x plus 10 equals 3. And what that really means is that there must be something, in other words, there must exist a number x. Of course, I'm still talking about the real numbers. Such that this equation does not hold. What does it mean for this equation to not hold? It just means x plus 10 will not equal 3. So symbolically, what we're doing is we're getting a there exists statement out of a for all statement. So I negated the for all statement, and it turns into there existing something such that the predicate doesn't happen. So now this guy not working for all the real numbers means that there exists a real number such that the predicate does not come true. So what does it mean for the predicate to not be true? It means that. So this is what we were looking for. That's what this is equivalent to. And in general, this is exactly how it works. So in general, if you do a negation of a for all statement where x is in something, and then you claim that for all of those possible x's that something happens involving them, some predicate happens, then that is equivalent to saying, well, if that's not to occur, that means that there has to be something in those possibilities which make the predicate not happen. So you negate the predicate. And so this is exactly how the negation works with the for all. It just flips it into a there exists, and then you negate the predicate, which is exactly opposite to what happened up here. So they're they do come in pairs. I don't know where I wrote the rule, somewhere up here. Whatever. Okay, I'll just summarize both. So here's the other one. If you negate a there exists, it becomes a for all, and then you negate the predicate. Okay, so let's apply this one to another example, so if I say for any x in the real numbers, and then I say something happens, x squared is bigger than x. So first let's figure out its negation, and then we'll think about which one is true and which one is false. So the negation of this is that there's some number which makes the opposite happen. So for any x in the real numbers, x squared is bigger than x is equivalent to saying that there's got to be something such that this thing doesn't happen. Well, what is it? If this is p of x, what's the negation of that happening? You might want to use some scratch work here. Well, the negation of x squared being bigger than x is that x squared is less than x, but this is not exactly correct yet because you have to also include the possibility of it being equal. Okay, so which one of these is true? The second is true, the negation is true. So you might think, yeah, x squared is bigger than x, I knew that. Well, did you? Because it is true most of the time, but not for every real number x. That's the key. So yes, the second one is true. This guy is true. And this one is false. And it's true because there are times when x squared is less than or equal to x. For example, 0. So there does exist an x in the reals such that x squared is less than or equal to x, because if I use 0, I get 0 squared is less than or equal to 0. You don't even have to use 0, actually. There's lots of things that work. You could use like a half. So if I square a half, I get a fourth, and that's less than or equal to a half. So it is not true that for every number you use, x squared is bigger than x. It's only true sometimes. So that's why the negation is true instead, that there exists something which makes it not work, which makes x squared less than or equal to x. There's lots of examples. Okay, let's do one more example, and then that'll be it for this video. There exists an x in the real numbers such that x squared plus 1 equals 0. So right off the bat, I will tell you that this one is false. And it's because the only solution to this guy involves imaginary numbers, not real numbers. So you have to think about I. So that's why it's false. So let's look at the negation, because the negation will be true just because it's the opposite of a false statement. So the negation will be that I'm in this situation, so let me just use little shortcuts to help me. So what that means is the negation is going to look like a for all statement in whatever numbers you're talking about, the real numbers in this case. And then you're going to negate the predicate by, instead of saying that it is equal to 0, saying that it's not equal. So then does this sound true to you? Because it should be true. Any real number that you plug into x squared plus 1, it'll never be 0. Yes, that's true, because you need the imaginary numbers to make that happen. So yes, that is true. So the important skill is to remember how the negation works with the for all and there exists, but also, just as important, is being able to negate things like this. So keep this in mind. What's the negation of that? It's a less than or equal to. What's the negation of an equal sign? It's a not equal sign. What's the negation of a bigger than or equal to? It's a just less than. And then there's other things, like you could say like x is even. Well, this one's a bit tricky. You might think it's odd, but you should be more careful than that. Instead, you should just say it's not even. So you sort of have to look at the individual problems to see how to negate the predicate in each specific scenario. Okay, so that is it for today. I will see you next time.